In this session, I am going to talk about Enterprise Automation Framework. Enterprise Automation Framework is a test automation framework that helps to achieve automation of end-to-end tests. Before we proceed, let me introduce myself. I am a test automation architect with more than 11 years of experience in end-to-end design, development, implementation, and maintenance of automation projects. I have helped organizations gain the full benefits of test automation using right automation tools, automation frameworks, and automation processes. I have worked on a wide variety of test automation frameworks, including data-driven framework, keyword-driven framework, page object model-driven framework, agile automation framework, and enterprise automation framework. Among these frameworks, agile automation framework and enterprise automation framework has solely been conceptualized, designed, and developed by me. I am also author of Pearson published books like Test Automation and QTP, Selenium WebDriver, and Agile Automation and UFT. So in this session, we are going to talk about Enterprise Automation Framework. This framework has been designed to achieve automation of end-to-end tests. The complete code of Enterprise Automation Framework is available on GitHub. Before we proceed with what Enterprise Automation Framework actually is and how it can be used to achieve end-to-end test automation, let's first define what end-to-end test is when it concerns to Enterprise Automation Framework. Anybody would like to say what end-to-end test means to him?
User action results in, has a result, an end result after passing through some code and perhaps components outside of remote components.
Anybody else would like to try?
So as we see, the definition of end-to-end test keeps on changing depending upon audience to which we ask this question. Suppose we go to the product owner of a banking application, say bankofamerica.com or chase.com, and if we ask him what does end-to-end scenario mean to him, then a typical answer would be, for him, when a customer opens up the Bank of America site, logs in, and then tries to execute a transaction like say a fund transfer transaction, and as soon as he completes the transaction and gets the transaction number, that is the point where his end-to-end test ends. But if you go to the product owner of a corporate banking application, what he would say is his end-to-end scenario starts when customer goes to the customer facing site like bankofamerica.com and creates a fund transfer transaction. Then that transaction moves to a corporate banking application, and in the corporate banking application actual debiting and crediting happens, and when finally when the accounts has been credited or debited, that is the time when end-to-end test scenario ends. Let's take another example. Let's consider retail applications like Amazon.com or biglots.com or Kmart.com. Suppose we go to the product manager of say Amazon.com site and ask him what an end-to-end test scenario would mean to him. Then a typical answer would be end-to-end scenario starts when customer launches the site, searches for an item, adds that item to the cart, then inputs his billing, shipping, and credit card details, and then finally clicks on the submit button. And thereafter, he lands on the order confirmation page and he gets his order confirmation number. So this is the point where an end-to-end test ends for him. But if we ask the same question to the product owner of an order management order management application, then a typical answer from his side would be that an end-to-end test for him would start at the point when a customer creates an order from a customer facing application, like it would be the web application, it could be the mobile application, it could be iPad application, or it could be a point of sales application, or it can even be a call center applications where customer can call and place orders. So that is the starting point of an end-to-end scenario. The same order transaction then moves to order management application where order processing happens. During the order processing phase, it is defined from which distribution center or from which store the order will get shipped, when the customer is going to receive the actual order, which shipping mechanism would be chosen, whether it would be UPS, USPS, FedEx, what kind of taxes would be applied, how the payment authorization will happen. All this processing happens in the order management application. When finally all this processing has happened and the order has been shipped to the customer and received by the customer, that is the point where an end-to-end scenario ends for him. So as it concerns to enterprise automation framework, we are trying to automate end-to-end tests which cover the complete transaction life cycle. Like for a retail application, the transaction life cycle starts from the point a customer has created an order and it ends when the finally customer has received an order. For an insurance application, the transaction life cycle would start when the customer have created a claim in the customer facing application, and finally his claim gets fulfilled with the actual credit or to his account when he finally receives his check. That is the point where the transaction life cycle would end. So the main objective of enterprise automation framework is to automate the complete life cycle of a transaction. In case of insurance applications, it would be claim management life cycle. In case of banking application, it could be a transaction management life cycle. In case of retail application, it could be a order management life cycle. In order to explain what enterprise automation framework is and how it can be used to automate complete life cycle of a transaction, we will consider order management life cycle as an example. In a typical order management life cycle, the order life cycle starts when the customer creates an order using any customer facing application. Thereafter, an order entry is created. The entered order is then processed. Thereafter, billing happens, and thereafter in distribution center or store, the order is picked and packed. Finally, the order is shipped using FedEx or UPS or USPS, and finally a tracking is done till the order is delivered to the customer. Finally, when customer receives the order, this is the point when order management life cycle ends. So to consolidate, the order management life cycle starts from the point when customer creates an order and it ends when customer has finally received the order. So to summarize what end-to-end testing is, end-to-end testing is a methodology to test the flow of information between various applications is working as designed from start to finish. The objective of E2E tests is to identify application dependencies and ensure information flow is seamless and correct information is flowing between various applications. In E2E testing, the entire suite of applications is tested in a real-world scenario such as communication between online apps, order management application, payment application, etc. Now before we proceed with what enterprise automation framework is and how it can be used to automate end-to-end tests, let's first try to understand why end-to-end testing is necessary. Now as we know, end-to-end testing is a time-consuming and resource-intensive process. Two reasons for the same being, end-to-end testing spans across multiple applications. Like for if I want to test say order management life cycle, then it will involve order capture applications like the .com site, the point of sales, the call center, the Android applications, the iOS applications. Then it will involve order management applications. Then it will involve supply chain management applications. Then there could be a legacy applications like the pick pack ship applications in distribution center. Then there could be an email management application. There could be more applications like business intelligence applications, payment management applications, rewards management application, etc. So if I want to test an end-to-end scenario, the transaction should traverse through all these applications. That is, we have to test in each and every application before we can say that end-to-end test is complete. Also, if you want to say that if you want to test an integration test scenario, then also we have to test one or more of these applications in order to certify that no integration bugs or interface bugs exist. Now, as we have now concluded that end-to-end testing is very time consuming and resource intensive process. Now, since end testing involves multiple applications, it's a very time consuming and resource intensive process. Resource intensive because it involves the functional experts of all the teams. All these functional experts should come together at a given point of time to perform this testing. Now, in current agile dev world, each and every organization wants to go to production faster. There is a need to deliver the features faster to customer. End-to-end testing being a very time consuming and a lengthy process does not fit within the agile time bandwidth, and this results in sometimes end-to-end testing or even the integration testing getting ignored. Now let's first understand what would be the implications of end-to-end testing or integration testing getting ignored. Let's consider there's one organization who wants to implement a new gift card, who wants to launch a new gift card in production during Thanksgiving sale. So the order capture team goes ahead, performs requirement analysis and implements it and launches it in the production. After they go live in production, they observe that the gift card image is not getting populated correctly in the order confirmation emails that customers are receiving. Now this is a kind of a reputation loss to the customers, because if a gift card is specifically being designed and launched for Thanksgiving, the image has a lot of context to that, and if that image itself is not getting published in the order confirmation emails and customers are not able to see it, then it means that something has gone wrong, and customers are not getting the right value from the gift cards that they bought. Now let's analyze why this happened. This happened because order capture team did not consult the email management team and did not provided them the right kind of a new image URL so they could have implemented in their application. What it means that the integration testing or end-to-end testing was never done. There could be a multiple scenarios where end-to-end, where an interface bug or a contract bug can migrate to production. And when it goes to production, it can essentially bring lots of losses to a company. So the need of the hour is not to ignore end-to-end or integration testing, but these are to be done in a way that it fits within agile time bandwidth. There could be many ways of doing it. One way of doing it could be you start using stubs and do the testing in a 4 walls. Another way is to automate a lot of contract tests. That helps us automate all the interface requirement and test it whether the information is flowing correctly or not. Another way of doing it is to automate the end-to-end test. When we will automate the end-to-end test, it will reduce the time that is required to execute an end-to-end test. Also, it will reduce the dependencies that we have on the resources. So far we discussed what end-to-end testing is and what are the benefits of automating an end-to-end test. Now, before we move on to how enterprise automation framework can be used to automate an end-to-end test, let's first understand what are the challenges that we can face when we try to automate an end-to-end test, and how enterprise automation framework helps us to overcome those challenges. The first and foremost challenges that you must also have faced when you try to automate a scenario are the social challenges. The two major social challenges are, the first one is when an automation expert goes to a functional expert to get a know-how of how a functionality works, sometimes it happens that a functional expert gets a feeling that if he passes on to the knowledge of the work that he's doing on a daily or weekly basis, and that scenario gets automated, then what he will be doing. Another kind of challenge that automation engineers face is that when they go to a functional expert, they get to know that functional experts are really busy in their own work schedule or with their own workload, and they do not have enough time to devote it to the automation engineers to explain the complete functionality. In coming slides, we will see how enterprise automation framework proposes to develop a stabilized solution that reduces the communication between automation experts and functional experts. From this slide onwards, we will discuss the technical challenges that we can face when we try to automate an end-to-end test. The first technical challenge is multiple applications. As we discussed, for any transaction lifecycle, there exist multiple applications within an organization. Suppose for a typical scenario, for order management lifecycle, there exist order capture applications, order management applications, supply chain management applications, legacy application, and email application. This is the hypothetical scenario. In a real world scenario, there could be more applications like rewards management application, payment management application, business intelligence applications, etc. Now, if we want to automate an end-to-end test, it would essentially mean that we want to automate all these applications. Now, in order, there's no single tool exists in the market, no single automation tool exists in the market which can claim to automate all the application that exist in an organization. So it eventually means it is very difficult to write automation test that can automate kind of all of these applications. So this is one of the most common and the most this is one of the most important technical challenge when we try to automate an end-to-end test. Next is the limited time and budget. In current agile day world, there is increasing focus on reducing the testing budget as well as to increase the efficiency of testing. And when it comes to end-to-end testing, we know that it is very time consuming and resource intensive process. So if we want to automate it, what it means that we have to ask for a lot of budget, a lot of time to automate a complete end-to-end scenario. In coming slides, how we will see that enterprise automation framework provides a platform from where end-to-end tests can be we can start automating end-to-end tests within no time. The next challenge is variety of test tools and languages. In any given organization, different automation teams use different applications. Suppose a situation where order capture team is using Selenium with some of their agile teams using Java, some of their agile teams using VB, and some of their agile teams is using Scala. Suppose the order management team is using open source tools with just Java code, supply chain management team is using HP or other tools. Now, none of these tools are compatible with one another. Also, none of the coding languages can seamlessly integrate with one another. So it's very difficult to write a test using any of the given tools. Also, consider a scenario where we decide that suppose if you want to reuse the test for end-to-end testing, suppose whatever the test that has been created by order capture application, we want to reuse them. Just reuse those tests, execute it, and see how an end-to-end scenario looks like. in that situation also it becomes very difficult. Suppose the order capture application has executed an end-to-end scenario, and the code exists in Java, and order management application code say suppose the supply chain management code exists using sorry, the legacy application code exists in VBScript. Now Java and VBScript are not easily integratable with one another. So how the VBScript code will proceed from the point where the Java or VB code has left. So this is again one of the bigger challenges when we try to automate an end-to-end test. The next big challenge is time lag. If we consider a complete life cycle of a transaction, there are certain applications which take time to process a transaction. Like in this example, order management application takes 5 minutes to process an order. Supply chain management application, it will take 10 minutes to process an order, and so on. Suppose if you want to write one end-to-end test, then what would it mean that after creating an order in order capture application, the test needs to pause for 5 minutes before performing any action on order management application, and similarly it needs to again pause for 10 minutes before it can perform any action on supply chain management application. Now from experience we know that the lengthier a test case is, the lesser it would be on stability. That is, if the test case is the test case code is huge, the higher is the chance it's going to fail. Now there is no point writing a test case which is less stable or which is flaky in nature. So this is also one of the bigger challenges. We'll see how enterprise automation framework provides as a conceptualized model which can be used to overcome this problem. So while we were thinking on enterprise automation framework, and as we discussed also in later slides, that end-to-end testing is very time consuming and resource intensive. So while we were thinking and what to do and which framework to develop, it came to us that we need a framework that would hold true for the whole organization, not only for one application or two application, but the same automation framework could be reused across each and every application and each and every application team. We were also of the understanding that most of our application teams have their own automation team, and they have developed their own automation tests. Now if you want to rewrite the automation test, then it will essentially mean that we are redoing things, which is not advisable. So first decision we made is to ensure that we are not going to develop or write the code again. We are going to reuse the automation test code that has been developed by the different application teams, and we will reuse these automation tests to create an automated end-to-end scenario. Now when we had decided that we are going to reuse the automation code, the next problem in front of us is all these code exist within different automation tools and with different languages. So how to integrate all these tools and languages in a way that will help us to automate end-to-end tests? At that point, we made a decision that we are going to use Jenkins as our tool to execute the test. Jenkins is a build management tool that helps to execute automation tests written using any automation tool and any coding language. So now we had made a decision that we are going to use Jenkins to execute our automation suite. One more decision that we made here is each and every what we are trying to do is each and every team will develop their own automation suite. Like order capture team will make their automation suite, and also the order management team will make their own automation suite. Supply chain management team will create their own automation suite. For each and every automation suite, we are going to create one Jenkins job. The next challenge in front of us is we cannot execute all these Jenkins job in any sequence. They have to be called in a definite sequence. Like the order management Jenkins job needs to execute only after order capture Jenkins job has got executed. This is essentially for the reason because if I want to verify a transaction in the order management application, the order needs to be first created in the order capture application. To solve this problem, we came with the idea of using Jenkins pipeline. Now Jenkins pipeline offers a feature where different jobs can be programmed to call in a specific sequence. Once we had solved this problem, we came up with another challenge. Almost each and every team had developed their own reporting mechanism, and none of these reporting mechanism was compatible to do the other reports. They were good as far as their respective application is concerned, but when it concerns to the organization or enterprise as a whole, the reports were not generic enough to suit the requirements of each and every application team. So we came to a conclusion that enterprise automation framework will offer a platform which will help us to generate a generic set of reports, and these reports will be so generic in nature that it will meet the requirements of each and every application team. Also, enterprise automation framework will have its own database where it will save all these execution information. Also, we decided that we can achieve this using a test data modeler which will be developed inside the enterprise automation framework. Also, we decided that the enterprise automation framework will have its own enterprise test data which can be used for testing. We will discuss this more in coming slides. So far we discussed what are the challenges that we can face when we try to automate an end-to-end test. We also discussed a very basic overview of what enterprise automation framework is and how it tries to solve the various problems. Now in this session, we'll specifically target each and every challenges that we have discussed, and we'll try to answer how enterprise automation framework helps us to overcome those challenges. The first challenge that we had discussed was the social challenge, where functional experts are quite busy and they would not be able to devote a lot of time to the automation expert. An essential solution to this problem is to write the test cases in a way that they are self-explanatory. So if the test cases are detailed enough, the interactions between the automation experts and the functional experts could be minimized. Now let's consider a scenario where we have a test case, say create one-day shipping order. It has got 5 test steps: create order, validate order in order management application, validate the order data is correct, validate inventory decreases by the quantity ordered, and validate order payment is done successfully. Now any of you can point out what is a major drawback of the way in which this test case has been written. The major drawback of this test case is it does not defines the application against which the specific test case needs to be executed. It says create order, but create order against .com applications, Android applications, iOS application, which application? When a test team is executing the same end-to-end test again and again, they know which test step needs to be executed against which application. But if you provide this test case to a different to a functional expert of a different team or to an automation expert, it would be very difficult for him to know what to do about this test case. So the first thing that we decided is to ensure that each and every test step for a given end-to-end test should have a defined application against which this would be executed. So we've transformed this test case into something that you can have into something like this. For each and every test step, there exists a system and application. Like for create order, it needs to be executed against mobile applications. Step 2 and step 3 needs to be executed against order management application. Similarly, step 4 needs to be executed against inventory management application, and step 5 needs to be executed against payment management application. Since now each and every test step has got a predefined application, the test cases are more self-explanatory. Now, when we started designing test cases in this way, we faced another problem. So suppose we have got 100 test cases, and for all these 100 test cases, test steps are defined top to bottom. So what would essentially this means that user needs to keep on scrolling down to get a gist of the test case. And if the test step is say very long, say for 20 steps or 25 steps, then it becomes very difficult to give. What it actually means is the test case becomes less readable with the increase in the number of test steps and increase in the number of test cases. So what we thought is, instead of defining the test steps from top to bottom, why not define it from left to right? So we came to a conclusion that test cases would be defined from top to bottom, while test steps would be defined from left to right. And we'll specify only the applications against which it will be executed. Like for test case 1, step 1 needs to be executed against order capture application, and the next step would be executed against order management application, the next step against inventory management application, and so on. So this way we have got a end-to-end test which is self-explanatory, as well as it is good in readability. Now from this slide onwards, we'll discuss how enterprise automation framework helps us to solve the technical challenges that we can face when we try to automate an end-to-end test. So the first challenge that we had discussed, that for any end-to-end test, the transaction traverses through multiple applications. So if I want to write an end-to-end test, what it actually means that specific test should automate all the applications. And an important problem with this is there does not exist a single automation tool in the market that can automate all the applications of a given organization. Also when we thought of the decision that why not reuse the automation test of the existing application, in that scenario we faced another problem, and that was none of the automation tools and none of the coding languages can seamlessly integrate with one another. So we thought that one way we can solve this problem is by using Jenkins job. Jenkins is a build management tool that helps us to execute automation tests written in any coding language and written by any automation tool. So we thought that we'll reuse the existing automation infrastructure and existing automation resources of each and every team to write an automated test, and we can use Jenkins to execute all of these tests. The next solution that we discussed is as we know that all these tests need to execute in a specific sequence. So the next step to solve this problem is use the Jenkins feature to define the sequence in which these Jenkins jobs would get executed. Now we have made this decision. Now anybody can tell what would be a major problem when executing this Jenkins test. An important problem is, suppose I execute 50 tests during order capture, and then I have to execute the order management test. Suppose order capture has created 50 test orders, and during order management phase I need to validate that the order information like billing details, shipping details are correct in order management application. The first problem is how would order management automation suite would know which are the order numbers and where they are kept, because it needs those order numbers to verify it. So first problem is from where it will get those order numbers. Suppose we make a decision that will keep those order numbers in a shared file, a shared directory which is shared among both order capture and order management application. The next problem occurs is, suppose there are two test cases. There are two test cases in order capture application, say order capture 001 and order capture 002. Suppose these generates order number 001 and order number 002. Now, how order management automation suite would know that order number 001 corresponds to test case 00, that is order capture test 001. So it needs to differentiate that which order number corresponds to which test case. And this is the point where enterprise automation framework comes to our rescue. Enterprise automation framework provides its own framework APIs. So the solution here is, whenever any automation framework extends to automation enterprise automation framework start listening to the execution process. It captures the test case that is getting executed, the priority of the test case, the name of the test case, and when the test case ends, it also captures the execution status of the test case and also any other information like order number, transaction number, claim number, etc. All this information is captured and stored within enterprise automation framework. Any automation framework can interact with the enterprise automation framework using its APIs. So when the order capture tests run then all this information is stored within the enterprise automation framework. So suppose when order capture Jenkins job has stopped execution and order management job needs to start execution, as soon as order management job starts execution, it will first establish a contact with enterprise automation framework, and it will try to fetch the specific order numbers and this given status. So in this way, the order management test cases will be able to differentiate like for which test case which order number needs to be used. Also consider another scenario where suppose we execute 50 tests in order capture and 5 test cases fail. Now since these 5 test cases has failed, we may not want to execute these 5 test cases in order management application. Essentially these 5 test cases needs to be skipped. So how enterprise automation framework here helps is, before order management test suite starts executing, it sends a request to the enterprise automation framework to ask whether this test case, say test case 001 has passed in its last step or not, and the enterprise automation framework responds. So if order management test gets a positive response, then it will continue with the execution of that test case. If not, then it will skip that test case and proceed with the execution of the next test. This slide shows a typical example of how database field looks like. It's not an exact replica, but it will give you a brief overview of how it works. Let's just consider an example of the database field between order capture application and order management application. Suppose order capture tests have got executed and it has updated the enterprise automation framework database. In an enterprise automation framework uses SQLite as its for storing data. This is because SQLite is a serverless database. This database can be created using code and can be created using runtime, and this is the basic reason why we chose this database. So now let's have a look at the various fields. So the enterprise automation framework databases have got information regarding the manual test name, the automated test name, the last executed step, the unique identifier. The unique identifier could be a order number, for retail application, transaction number for banking application, insurance number or claim number for insurance application, etc. The transaction details file, it will contain the details of a transaction. Suppose an order is created in order capture application, and the requirement is to validate the billing details, shipping details of the transaction in order management application. This is to ensure that the information passed between order capture and order management application is correct. In those scenarios, the users can code to store the required billing details or shipping details or that any other transaction details in an XML file or a JSON file. The same XML or JSON file is stored in the database, and when order management test executes, they can read from this database and then verify against the order management application. The next is the status, which says whether the given test has passed or failed. The next is partially automated. So in case if we consider a given organization, there would be many application teams, there could be some application teams which have not started automating their tests, or they are completely manually driven. It could be include like legacy applications like based on AS400. So those applications may have only functional testers and they may not have any automation tests. In those scenarios, this framework offers a feature to define such tests as false. What would it mean that suppose here in this case, when supply chain management job has executed, it will automatically trigger an email to the legacy application team. The functional experts of that team then go ahead and execute that test, and once they have executed the respective test manually, they can go ahead and trigger the email Jenkins job. And another scenario would be if we do not want to hand over the triggering of the jobs by the team because it's a manual process, we can schedule the jobs. For example, like if we understand that the manual team takes somewhere around 30 minutes to go ahead and execute the test, we can schedule the job to execute after 45 minutes on an hour. So the email Jenkins job will automatically get triggered after a given time. The essential now let's consider the another table that is shown in this slide, the table between order management and SCM job. An essential difference that we see here is the last executed step has got updated. One thing to note here is the last executed step has got a specific naming convention. It starts with E to E, and the second name is the name of the application against which test is getting executed. So if the tests are getting executed against mobile, we can say mobile application. If the test case is executed for iPad, we can say it's an iPad. The next step is the name of the applications. Like the first step got executed against order capture application, so the name is order capture. In the second table, the same test got executed against order management application, so the name gets updated to order management. And the last name IT is the common name that we use. Now, enterprise automation framework is capable of developing its own set of reports. There are two kinds of reports that it generates. The first is a JSON report, and another one is an HTML report. So this is a layout of how a Jenkins report looks like. This is the HTML report. The HTML report has got three tables. The first table denotes test execution summary. The second table has details for a test step execution summary, and third one contains details of all the tests that got executed. Test execution summary table gives a summary overview of all the test steps. So suppose when the order capture test got executed, out of 50 tests that we executed, 5 tests got failed. And when we proceeded with the order management job, again again 2 tests got failed there. So till the time order management test got executed, we executed 50 tests, out of which 8 tests failed and 42 tests passed. So this would be a snapshot view of the test execution summary. Now if we look at the test step execution summary, it will say that it has executed 50 tests, out of which 3 tests failed and 5 tests got skipped, and the remaining 42 got passed. So 5 tests skipped here means that these tests did not fail during executing the module order management. They failed when they were when they failed in the previous execution steps. Also, these HTML reports are being generated for each and every Jenkins job that gets executed. So, and the reason for doing so is that once a Jenkins job gets executed, each and every application team can go and look into these reports, and they can also filter out for their own team and see what failed for their team and how they can fix it. The last one is the detailed execution report. So it contains information regarding the test case name, its execution status, if it has failed, what is the reason of the failure, and it also contains timestamp of what was when was what at what time exactly it failed or passed. It also contains details like where the transaction details files are kept, etc. This complete HTML report is responsive in nature, so it can be viewed either in mobile devices or desktop devices or iPad devices, etc. Next, coming back to the features of Enterprise Automation Framework. So Enterprise Automation Framework as of now exists as a jar file, and the main objective of doing so is to ensure that any automation tool and any automation tool coding language will be able to interact with the Enterprise Automation Framework. It has specific support for TestNG framework. If any team is using TestNG framework, it can directly integrate with the Enterprise Automation Framework. However, if TestNG is not being used, then they might need to use the jar file. In the jar file, we have certain interface methods. Those methods can be used to update, to integrate with Enterprise Automation Framework. In future, we also plan to upgrade this Enterprise Automation Framework as REST services, so that any automation tool and any coding language can easily interact with it. Next thing is, no major changes is required to integrate with Enterprise Automation Framework. Enterprise Automation Framework provides its own set of APIs or interface layer, and as soon as the framework extends to these API layer, it will be easily able to integrate with Enterprise Automation Framework. No major chunk of code is to be written. Enterprise Automation Framework provides its own sets of methods like create test case, update test case status, etc. So the only requirement is these methods needs to be called at specific times, so that Enterprise Automation Framework is able to capture and store the execution information. For TestNG on Java, a user may not be able to do that so even, because it automatically has got its own set of listeners to capture and store this information. Also, Enterprise Automation Framework develops its own set of reports which are generic in nature and can be consumed by all the application teams in any given organization. This is the architecture model diagram of Enterprise Automation Framework. At the top is the enterprise test model, which contains information like what kind of test information we are going to capture from the users and how it will be organized. Information like the test case name, the manual test case name, automated test case name, the test case status, the transaction details file, its priority, etc. E2E test base is the interface layer between the external environment and Enterprise Automation Framework. It contains methods like create a test, update test status, etc. This test base class is also responsible for updating the SQLite database with all the test execution information. Also, this class is responsible for generating the JSON and HTML reports. So all the external applications or automation code that needs to interact with Enterprise Automation Framework needs to interact with the interface layer. Also, we have another storehouse for test data called Enterprise Test Data. One basic reason of having a separate test data storage is because when we talk about enterprise, enterprise end-to-end test automation, that we need to ensure that test data exists. The same test data with same attributes exist in all the applications across the organization. Like let's consider again the retail application. Suppose a customer we want to automate a scenario where we say that customer wants to create an order of buying an item, say kayak item. Now we have to ensure that the kayak item is not only present in the order capture application, but it is also present in order management application. It's also present in inventory management application. It is also present in our legacy applications like AS400, where pick pack ship happens. Also, we have to ensure this kayak information, the attributes of this kayak, like it's oversized, etc. The attribute information needs to be same across all these applications. In order to ensure that we have got a correct data with correct information, we try to ensure that we have a separate data storage for it. So all this test data is stored within the Enterprise Automation Framework. So if any automation stream is trying to create a transaction, it needs to use this test data to create a transaction. This will ensure that we are using the right kind of test data and the tests are not failing because the test data information is incorrect between any of these applications. So this was all about Enterprise Automation Framework. Do you have any questions on this?